together. Let's start our today's lesson. So our today's lesson, it is the interesting topic in chemistry. We started chemical kinetic. So we'll finish. So we'll answer Rate law. We'll try to answer different questions on rate law. So we'll finish rate law. After that we'll have another topic, then chemical kinetic will end. It is simple and easy. Yes. So rate law. What is this rate law? It is just a mathematical expression which describe the relationship between the rate of chemical reaction and the rate of concentration of the reactant. That's all. It's just a mathematical expression. That's all. Yes. So we are saying that rate law, it is just, or it is a mathematical expression. So it is a mathematical expression. So it's a mathematical expression which describe the relationship between what? Between the rate of chemical reaction. So rate of chemical reaction and concentration of the reactant. That's all. So we are saying that it's just a rate law. This is just only a mathematical. The rate law is just a mathematical expression which describes the relationship between the rate of chemical reaction and the concentration of the reactant. That's all. So this is just on the mathematical expression. Let's write the formula for the rate law. So the formula for the rate law, it is let's write the formula for the rate law. So what is the formula? So rate is equal to K A M B and N. So that is the formula for rate law. We just need to know this formula. K, this is a constant. This is a concentration constant K, and then so it's a rate. So K is a rate constant, A the reactant, and B the reactant. Remember this. So remember what I said. So that is the formula. Rate is equal to what? K A M K A and B are reactant. K, it is the rate constant. Now I like always when I'm teaching chemistry, I like using letters. A plus B, it gives us what? C plus D. Remember on rate, we only deals with the reactant, which is A and what? B. So that's why the formula for rate, it only has A and B. That is the reactant. And when you go to M and N, what is M and N? Those are what you are calling reaction orders. We'll learn this, how we can calculate these reaction orders or their powers. Yes. So A and B, they are concentrations of reactants, because they are the definition of rate law. It's just a mathematical expression like this one. We are seeing it's a mathematical expression. Yes. And they can give you questions to express in late form or in late order. Let's give an example which is in the document which I've already prepared. There, example, can say example, wow, write like that. So C, I'll do C plus what? Plus O2 giving us, so carbon plus oxygen gives us what? CO. So gives us CO2. Now the question is, given that second order of carbon and zero order of oxygen express in rate law. Let's write the question. We can give you this question at expression rate law. So given that second order of, so second order of carbon and zero order of oxygen, zero order of oxygen, then they give you express in rate law. How can you express if they have given you this question? Given that second order of carbon and zero order of oxygen, then express in rate law. So you need to know the formula. The formula is just simple. You say rate is equal to what? So rate is equal to K. It only deals with a reactant. K A, then M B N. That is the formula. And M and N are reaction orders. A and B are reactant. So how can we express in rate law or in rate form? So rate is equal to what? K. Then A will put the reactant. We have carbon. So put carbon. Then M, according to the question, you go, given that the second order, so this is the key. This is the key expression which says the second order of carbon and zero order of oxygen. So second, so order. So this means this M and N, they are what? They are orders. So carbon, they said it is second, so it is 2. That is the order. What about B? We write the reactant, the second reactant, which is what? Oxygen. So write O2. O2 as what order? Oxygen as what order? Given that second order of carbon and zero order of oxygen, so oxygen has 0. That is how we express in rate law. So K, we write K, then the final answer is what? C to the power 2. That is because here 0 to the power n number to the power 0 is 1. So just write K is equal to what? That is the only way we can express in reaction order. So it is simple, easy, and straightforward. Now you know how you can express in reaction order. Now they can give you questions where they have experimental values to find now the reaction orders. We know how to express in rate law, but how can you find the reaction orders? Let's give an example for this question. So like we say example. So the question I've already prepared in the document, so you can access on our drive. The document is ready. So question, they said find the reaction order for the experiment of reactant of A and B in the table below. So the table is like this. Then this is a table. Then they say this is a trial. This is a trial. Then it has three parts. So here three part. Okay, not like this. Okay, we say like this. I draw. I don't have a ruler, but I'll try to draw straight. I'll try to draw so that it can be, or you can access, have at least drawn well on the document. So the reactants, we have A and B. Now there it is initial rates, and yes, it's like this, the table like this. So it has how many? 3 trials. So first, second, and third trial, like this. Okay, this bar. So it has reactant and initial rate. This is trial 1, 2, 3. So A first 0.5, second 0.6, third 0.6, and here 0.1, 0.1, then 0.13, also 0.4, 0.6, 0.6. So it has reactants. The reactant is A and B, and the initial rates, or the rates they have already calculated, which is 0.1. So the first round, they started on the first round. The reactant concentration was 0.5. So this will say, right, which is M for concentration, right, M. So the first round, they are dim the concentration of 0.5 for the reactant. For the second B, oh, it's not 0.5, was it should be what? Oh, it should be, okay, let me confirm with the document. Or it should be, here should be 0.4. So here should be what? 0.4. So the first round, 0.4 for the reactant A, the concentration for B 0.1. And when the initial rate, when you look at there, initial rate, it was what? 0.4, the initial rate. If they increased what? They increase the reactant A. If they increase the concentration of the reactant A, what happened? When you go where they maintained what? They maintained the concentration in B. The initial rate, or the rates, changed. So from 0.4 to 0.6. So the rate changed. So this means that A has effect on the reaction, because if the concentration of this, they increase the concentration, then the rates changed from 0.4 to 0.6. When you go it was maintained. Now they maintained, which is 0.1. They maintained the concentration in A. Then they say 0.1, then they increased a concentration in B from 0.1 to 0.3. What happened? The rates remained the same. So what can you conclude? So the reactant B has no effect in the on the reaction. So has no effect. If you increase, if you reduce, it will not affect the rate. So which means that it does not have any effect. Yes, but when you look at A, in A, it was what? 0.4. They increased to 0.6. It changed from 0.4 also to 0.6. So A has the effect on the reaction. Now they ask us to find the reaction orders. So the reaction orders. So reaction orders, when you look at rate is equal to what? K, which is the constant K, then K, then it is A, then M, then B, N. So they want the reaction order. So the M and N, their reaction orders. According to our question, they want us to find the reaction orders. So how can you find the reaction orders? So when you look at there on the table, to find the reaction orders, we need to pick two trials which are the same. So example, if you want the reaction order for B, we need to pick trials. The concentration in A should be what? Should be the same. So if you want to find the reaction order for B, so in A, so we'll pick trial 2 and trial 3 because they are the same. If you want to find for A, B, the concentration of B should be what? Should be also the same. So we'll pick 1 and 2. So we'll pick 1 and 2. Let's try to find the reaction order for A. Yes, for this A, for M, that is the reaction order for A. So for A, we want to do the reaction order. So for A, we said we'll pick 1 and what? 2, because B, it is the same. That is what we'll pick. Yes. So let's write the formula first. We have already write the formula. Then we will just replace. We have already calculated, which is what? 0.4. So write 0.4 is equal to K over A. A, the concentration, we use 1 and 2. So A as the concentration of 0.4. So we use 0.4 to the power M. Then B, what is B? B is 0.1 to the power what? To the power N. Then we divide. So I send the notes, the summarized note. I said we only divide when dealing with the reaction order. If you want the reaction orders, the formula is just to divide the first trial and the second trial, or vice versa, the second trial to the first one. Yes. So divide the second trial, which is what? This is the second trial. We divide with this. So it is what? 0.6. So 0.6 is equal to what? Then K, 0.4. So 0.4, write 0. Here it is 0.6, sorry, 0.16. Then we write M. Then we write for B. For B is what? So here 0.6 and 0.1. So now we know this. We have learned indices since grade 8, 9, 10, 11, 12. We were learning indices. Even to invest in mathematics, the first semester topic we have learned indices. So indices are simple. How we can divide. That is grade 1 week. So this will go. If this divide with this, will just go according to indices, because we subtract the n. N minus division, we subtract what? We subtract. So n minus n, which is giving us 0 to the power 0, is giving us 1 here. So 1 times this is 2. It is the same, it will go. So now K, even K will go. K into K. So we have 0.4 over 0.6 is equal to what? We are remaining with 0.4 M. So 0.4 M over what? 0.6 M. That is the only thing which will remain. So we can write in the form of this 0.4 over 0.6. We write it like this. So it's the same. Then here we can write even like 0.4 over 0.6. According to indices, we learned this. it is simple, because if we multiply here, it means m as the power of 0.6, it has the power of m, and 0.4 as the power of m. So this is the same. Yes, it is the same. So now here we have 0.4 over 0.6. Here we have 0.4 over 0.6. Now here we have to the power m, then 0.4 to the power 1. So when you look at here the equal sign, 0.4 over 0.6, so 0.4 over 0.6, 0.4 over 0.6, so 0.4 will go, and here, and also there 0.4 will go. So m is giving us what? Since 0.4 will go, there will remain with 1. So m will be what? M is equal to 1. So the reaction order for m is what? 1. Yes, it is 1. Now let's go to the other one. So the other one we will just answer from, you answer A, this space, it will be O. Let's go to the other one. So the other one we said D. Let's look at the other one. So we said D here. So we are found for N. So if we want for B, we need to pick two trials which are the same. So pick 0.6 and 0.6 or 0.6. So to our second round, third trial, because A is the same A. Yes. So pick these 2 and 3. Yes. So let's pick 2 and 3. So let, remember the formula for let. Let is equal to what? K, which is m to the power, it is a to the power m, then b to the power n. So let is equal to what? We write, so k, so we know now we will just replace according to there. So we have, this will be what? This is 0.6. 0.6 is equal to, so 0.6 is equal to what? K. Here A is also 0.6. M, we don't know M. Then B is what? So A is 0.6, B is 0.1. So 0.1. So 0.1 to the power n. So we divide, always we divide also. Here it is equal to what? Here also is 0.1, 0.6a. So 0.6 is equal to k, also 0.6 to the power m. Then the last one, it is, so 0.6 and 0.3, those are the reactant. So 0.3 right, to the power n. Now we need just to what? To divide now. So it is easy, you divide, k will go, k will go. Then this is the same, 0.6 m in indices, we learn this, then this will go, then we are remaining with 0.6. so 0.6 over 0.6 is equal to what? We are only remaining with 0.1 n over 0.3 n. Now we can write like that, like this. So 0.6 over 0.6 is what? 1 is equal to, here we can write 0.1 over 0.13. You can write like this to the power n. Yes. Now any number to the power 0 is what? We know if we put here to the power 0, it will give us 1. So n should be what? So n should be equal to 0. Yes. So m was giving us 1. So this is the only way we can find the reaction at the rate law. So we have finished the rate law. So our next lesson, we'll try to finish the whole entire lesson in chemical kinetics, because chemical kinetics is a simple topic. we end here for today's lesson, and we want also to start answering those tutorial simple tutorial sheet questions. We end here for today's lesson.